Hello, I'm your TA. In this video, I'm going to share you how do I answer my statistical scenario-based question in my homework, midterm, or final. Regardless of which class you're in, 680, 681, and 682, all the statistical tests should be conducted in this way. So first step is state null and alternative hypothesis. According to the null hypothesis, sometimes alternative hypothesis consists of not equal sign, which is two-tailed test. And when H1 include inequality sign, greater than or less than, this is one-tailed test. And H1 is what the researcher wants to know in the scenario. When you state the null and alternative hypothesis, you need to write specifically what kind of dependent or independent variable you are using. Writing the null and alternative hypothesis in generic way, that might lose your point in your homework or midterm or final. And step 2 is we need to calculate or we need to get some test statistics from the software such as SPSS, SAS, or R. Test statistics are such as T observed value or F observed value. According to the distributions they are following, test statistics are different, or P value. And we also need to know the critical value. Critical values are from table. Appendix in Howell. And we need to set the alpha. This is a significance level. Usually 0.05 in educational field. In medical field, usually 0.01 is used. However, according to your question in your homework, final, or midterm, if your instructor gave you a specific alpha, you need to follow that alpha. But if alpha is not given, you need to write your own alpha. So we need to calculate or get a test statistics or p-value from softwares or your hand calculation. And then step 3, we need to make a decision, which is reject the null hypothesis or fail to reject null hypothesis. I'm gonna give you the criteria. If absolute value of the test statistic is greater than absolute value of the critical value, we reject the null hypothesis. Because in the graph, for example, T distribution, especially in two-tailed test, we have two critical values, which is one is positive, the other is negative. So T critical value and T critical value. This is a positive one, this is a negative T critical value. After this one, we reject the null hypothesis. If my tested statistic, which is T observed one, is here, so this is the case of the absolute value of the T statistic is greater than the critical value, because the T observed value is in the rejection area. That is why we reject the null hypothesis. Test statistic is less than critical value. So test statistic is less than critical value. So my T observed value is here or T observed value is here, my red T observers are not in rejection area, we fail to reject the null hypothesis. I'm gonna show you one tail test example with F distribution. FC critical value is here. So after this line is my rejection area. If my F observed value is greater than F critical value, we reject the null hypothesis because F observed value is in the rejection area. However, if my F observed value is less than critical value, which is not in the rejection area, that is why we fail to reject the null hypothesis. So regardless of what kind of distribution and what kind of test statistic you are using, this applied to all the cases. So this is a criteria with test statistic. Second one, we can compare this one with p-value. If my p-value is less than alpha, we reject the null hypothesis. I'm gonna show you with example. This is T distribution. If I have T observed value, the probability of greater than the T observed here, I'm gonna highlight as blue. This is the p-value. And alpha is, if I have T critical value, after this one, so I'm gonna shade it with the red, this portion is alpha. For example, we set alpha as 0.05. So if p-value, the area of the blue is smaller than the alpha, we reject the null hypothesis because can you catch this graph and this graph are same one? Because here I compared only T observed value to the T critical value. However, in the bottom graph, I compare the proportion over T observed value and the proportion of after the T critical value. So we compare the area after the T observed value and T critical value in the bottom. And we just compare the test statistics and T observed value on the top. So anyways, this is rejection area. That is why we reject the null hypothesis. The same thing for the negative part. So below the T observed value, before the T critical value is rejection area, and this portion is 0.05, which is alpha. You can set your own alpha or alpha is given in the scenario. And if I have T observed value, the proportion is less than T observed value. I'm gonna highlight as blue p-value. So p-value is less than alpha, we reject the null hypothesis. If my p-value is greater than alpha, we fail to reject the null hypothesis. Let's see if I have, I'm gonna draw this way. If I have F distribution, I have F observed value. After the F observed value, the proportion of after the F observed value, this is my p-value. Alpha is the proportion of after the F critical value. So the red part is my alpha. So p-value is greater than the alpha, which means that F observed value is less than F critical value. We fail to reject our hypothesis because F observed value is not in the rejection area. I have one more criteria, which is confidence interval. Whenever you learn T statistic, F statistic, you have a formula how to calculate the confidence interval. So confidence interval, as you might guess with the name, confidence interval has lower bound and upper bound. If these two numbers contain hypothetical value, I fail to reject the null hypothesis. Hypothetical value is in the null hypothesis. So for example, my null hypothesis is mu is, for example, 10. So we need to check 10 is between the lower bound and upper bound of the confidence interval. For example, my null hypothesis is mu of pre-test minus mu of post-test is 0. This is my hypothetical value, so we need to check whether 0 is lie between lower bound and upper bound. For example, my confidence interval does not include hypothetical value. We reject the null hypothesis. We can make a decision by comparing test statistics and critical value, and we can compare p-value to alpha, or we need to check whether hypothetical value is inside of the confidence interval or not. So once we make a decision, we need to step 4, make a conclusion. In the context of scenario. In step 4, we need to think about significantly. We need to be careful when we use the word significantly. The goal of the statistic is we are going to make an inference the population from sample. For example, I want to know all women's height. Do you think that is it possible to measure all women's height all over the world? It might be impossible, right? So we sample only UNCG women's height. We can measure UNCG women's height. So we are going to make an inference from what we have to the population. So we can say significantly different in the sample level. However, the population level, the all women's height, this is the truth. So we cannot say significantly in the population level. My tip is when I use the significantly, I always try to write the word sample. For example, sample mean is significantly different from sample mean of another group, like that. When I use significantly, I always write the sample. However, when I make a conclusion about the population level, I do not write a significantly. And I would like to add one more here. In the first step, when we state the null and alternative hypothesis, this is for population. So we want to test population. We want to know the how population it is. For example, all women's height. But we only have the data in the sample level. That is why we are doing a statistical test. So because null and alternative hypothesis is for the population, that is why we use Greek letter. For example, mu, this is the population mean. And null and alternative hypothesis is for the population level. In the hypothesis, we cannot use significantly. So here we do not know significant. No. I'm gonna show you how can I apply all I explained with example. This is Howell 8th edition, exercise 7.14. Take a few seconds to read the scenario. In this scenario, what we want to test is, they also noticed that their scores on lie scale were higher than expected. And the information we have is the population mean for lie scale on the children's manifested anxiety scale is known to be 3.87. So we have sample 36 children under stress, and their sample mean is 439. So there might be a population, which is all children's lie scale score. However, we only have sample of 36 children. So we need to make an inference to population with the only sample. And we know the sample mean is 4.39. And population mean is known as 3.87. To answer A, I need to compare the lie mean score of these 36 children sample, which is 4.39 of population, which is 3.87 of young children tested under normal. And then the B is, so we need to write a null and alternative hypothesis. This is first step. State null and alternative hypothesis. Null hypothesis always include equal sign. So we want to know my population mean. This is a population mean. That is why I use the Greek letter. We want to know the population mean is 3.87. My alternative hypothesis is, as I mentioned on the top, alternative hypothesis is what the researcher wants to know in the scenario. In the scenario, the researcher wants to know that whether the score on the lie scale were higher than expected. So population mean is greater than 3.87. So this is my alternative hypothesis and null hypothesis. If you want to write as the hypothesis in Word, I would write as the population. And my alternative hypothesis, I would write as the. So you can write alternative hypothesis and null hypothesis in both mathematical notation or in a word. We need to calculate the test statistics, softwares, or hand calculation. And we need to find critical value, or we need to set alpha, which is usually 0.05 in education. And then we need to make a comparison. Because this is just a comparison, the sample mean and population mean, this is one sample t-test. So I would write as, I am going to conduct one sample t-test, and you need to add the reason why you do a one sample t-test. And by using SPSS or SAS or R or hand calculation, my test statistic, which is 1.2. And I found the critical value. I will write the critical value is this way because this follows the t-distribution and the critical value. So I would write the critical value is 0.03. Among the many methods I shared, I compared test statistic and critical value. So test statistic, I know my test statistic is 1.2 and critical value is 2.03. So I would write as, since my test statistic 1.2 and is less than critical value, which is 2.03. If I have p-value, this is what I'm going to write. By using test statistics. And my third method was using a confidence interval. So my confidence interval, when I calculated and when I got from the SPSS or SAS, my confidence interval, 95% confidence interval was 3.51 and 5.27. What is my hypothetical value? My hypothetical value is 3.87, which is in the null hypothesis. Because confidence interval contains 3.87, this includes 3.87. So we fail to reject the null hypothesis. So I would writing, since my hypothetical value, which is 3.87, is in the 95 confidence interval, which is 3.51, 5.27. And then I need to make a decision whether reject the null or fail to reject the null. Since my test statistic is less than critical value, or since my hypothetical value is in the 95 confidence interval, I fail to reject null hypothesis. And then I'm gonna copy what was in my null hypothesis. That the population and then we need to make a conclusion in the context of the scenario. So we need to make a conclusion in the So I have compelling statistical evidence that the population mean of life score in young population. To sum up, I'm gonna just highlight what I will write in the homework. So first, I need to state the null and alternative hypothesis. So I will definitely write these two lines with statistical notation and in Word, both of them. And I definitely write what kind of test I'm gonna do. So I would conduct one sample t-test with reason, and I will write a test statistic and its critical value, and I would also attach the confidence interval. If a question specifically asks you calculate the test statistic, I would follow this line. If your question specifically asks you calculate the confidence interval, I will also write this line. If your question does not ask you a specific test statistics or confidence interval or p-value, you can use one of the three, which is test statistic and critical value and confidence interval, or you can compare your p-value to alpha. Make sure that you need to make a note what is alpha you're gonna using if alpha is not given in your question. And then I'm gonna write, I failed to reject the null hypothesis, and I'm gonna write the null hypothesis. And then I'm gonna write the conclusion in the context of scenario. So I will write these three lines. I hope this video is helpful for you doing homework or midterm or final. Thank you for watching this video. If you have any questions, please email me. My email is s_kim45@uncg.edu. Bye.